Welcome to 3D Players, the podcast where we explore personalization in healthcare through advancements in 3D technology. We'll talk to leaders championing more predictable and sustainable patient care. I'm Pieter Slagmolen, joined by my co-host Sebastien de Boot.
Thank you, Peter.
Our guest today is Sebastien Henri, CEO of Pixie Medical, a French company active in augmented reality in orthopedics. Sebastien, in France, you're considered a technology pioneer in personalized orthopedic care, not only for the work that you're doing today at Pixie, but also for the work that you've done earlier in your career, especially in personalized knee guides. It's great that you'll share more with us, and welcome.
Thanks, Peter, for the nice introduction. So my name is Sebastien Henri. I'm 50 years old, but I started 25 years ago in computer-assisted orthopedic surgery. Computer-assisted orthopedic surgery is dedicated to help surgeons during orthopedic surgery to better position implant. When you are old, your cartilage is broken and you need to replace that with an artificial joint. And we created 25 years ago kind of GPS for orthopedic surgeons, helping them to better position implant. It was my first experience with computer placed in the operating room and surgeons trying to do their best to find better alignment or better implant positioning. 10 years ago, I created a new company dedicated still to the orthopedic industry, but using a new technology, custom jig, custom instruments, created around patient anatomy to better position also implant, but by using an instrument dedicated to patient. And 4 years ago, I created a new company. I think this is a new area for orthopedic assisted surgeries by using augmented reality tool to better position implant by using augmented reality glasses, but also a new range of planning and personalized planning or personalized implant in order still to better help patient.
And where did that personal motivation come from? Because to really go into and improve orthopedic procedures, and what triggered you to really build your career?
Yeah. I'm not an engineer, and orthopedic was an opportunity. It was not a choice. And I discovered a technology that can look at a first sight like traditional. An implant look like metal, plastic, and I like innovation in my personal life. And I discovered around this traditional industry a new way of thinking and the possibility to develop new tools to help patients to have better outcome after their surgery. I try to be driven by the idea that technology can help patients.
Mm-hmm. Mm-hmm. So in those 25 years, you also decided to become an entrepreneur. Why did you decide in the end to launch your own company and maybe leave the safe space of a larger medical device company?
To create a company was an opportunity because I had some ideas, but not the feeling that others will develop those ideas. So at one time when you have idea, and if you cannot see around you people willing to do that, you are taking your courage and you are going forward and you try to develop your own idea. And to be a pioneer is to do something that others don't want to try or don't want to develop, and it's really exciting. I have to admit that it's really exciting. So innovation in orthopedic is a nice place to develop your ideas.
And again, to continue on the history, at some point, OneFit Medical became a part of EOS Imaging.
Yeah.
How did they get to that decision, and how was that change for you?
Yeah, I created OneFit Medical in 2011, and we had a very quick growth. And I had one of my customers ask me to develop some planning tool. EOS Imaging is a French company created by one of our Nobel Prize. And they created a very sensitive X-ray detectors. And they developed a weight-bearing, low radiation X-ray system. But I had all the knowledge of how to develop software around this imaging system. And the combination of both technology, imaging plus dedicated instrumentation, customized instrumentation was nice because most of the imaging technology used to create custom jig was CT scan or MRI, and trying to work with a less radiation and weight-bearing position imaging system to create custom jig was very interesting. And as a very small company at the beginning, working with an established company was a good combination for my company. So working for EOS imaging, I was in charge of advanced orthopedic solution. That was mainly planning tool linked to this imaging system. So we developed a knee and hip planning. Hip planning was interesting because we were able to work with a patient in weight-bearing position, but also in sitting position with the capacity to analyze patient-specific way of the patient to move. Most of the time, imaging is static. Having the possibility to have two positions of your patient was very interesting, especially for the hip, when you can have a pelvic tick. It's a technical analysis of the movement of your pelvic according to your spine and to your leg in order to better plan, to create a patient-specific planning. And after that, we created patient-specific spine planning, Spineos, and we use for that kind of predictive model for a better alignment of your spine after the surgery. So personalization planning is to create a personalized planning for your patient. And with EOS, we had new opportunity to create such a planning for better patient outcome.
This is exactly why we were so eager to get you on this podcast, because of your vast experience in all sorts of different technologies and trying things out to come with a better execution of a plan and also better plans. It's great to hear all of those elements where you were involved. Today you are focused mostly on augmented reality with your new company, Pixie Medical. Why did you actually choose augmented reality as the technology to now go and spend all your time and energy in?
Augmented reality is a new world. And in this world, you can have many options that will change the way surgeons will just enter in the OR. First, augmented reality is a computer. It's a smartphone you can wear on your head, and with the potential to compute, to display, and also to perceive the 3D environment around you. Compared to traditional instruments that we use in the past, like traditional navigation systems that use a tracking system to get only 3D information, augmented reality glasses are more immersive solution with all what you need on your head. But the main advantage of this solution will just arrive in the next months. This is the connectivity, because you can connect to the PACS, you can connect to data, to server, to algorithm, to accessories. And I think really it will be a major change for not just orthopedic surgery, but for all the medical area, and probably more. My focus is on the medical area and especially the orthopedic. That's why Apple is launching next year a new augmented reality glasses, and they say it will replace the iPhone. So it's not just a tool, it's a new way of thinking with the potential. Not in 20 years ago, we had, I remember, the cell phone that was just to create a phone call. Right now, you have a smartphone with all the potential to detect the 3D environment with a new sensor and to create many features you want. It's like a Swiss knife. So I really think that it's a new era for orthopedic navigation. And we started with a tool to help surgeons to navigate their total knee replacements. And we create our own algorithm to perceive environment just by using a very small camera, same camera as the one you have in your smartphone. So this is the first idea, was to create a smaller instrument that surgeon will fit with zero footprint. And I would say that it's a success because we sold in less than 1 year more than 100 systems in Europe and in Australia. And we did the first surgery in the USA. So it's interesting.
It's clear indeed that the impact of this technology is pretty big nowadays. And the Apple reference that you make, I find it interesting because I also believe that as more of the big technology players come in, that the technology will be pushed forward and even create more opportunities. The value of Apple just on a single day went up by 100 billion because there was some announcement and buzz on what they were going to be doing in augmented reality, which is pretty exciting, I think, and I can hope that we see similar things happening in our industry of companies moving it forward like Apple is intending to do at the very least. So, yeah, exciting.
I was curious because you mentioned that in April you plugged something that you have in your pipeline more related to the fact that it will be connected. Can you explain what that will mean? Why will this be so revolutionary? What will be the exact difference?
Right now, we are using only the power of the computer that is embedded in glasses to compute the data that we can get from the sensor, so from the camera, from the deep sensor, from accelerometers, and we can display that in a screen, virtual screen, and we can create overlay on patients. This is traditional way to think about augmented reality. connectivity is a matter of data and multiple way to think about data. You can create your own data by using navigation, and those data can help next generation of patient to use those perioperative data to improve the operative outcome if you are doing this the right way. You can analyze patient data before the surgery, after the surgery, but perioperatively, you need to collect those data. And if you can combine all that together, you can create a new model that can help surgeons to create the right decision. So to be part with the connectivity of this new world of data that can be create new patient model, and why not predictive biomechanical model or predictive outcome model, is something very interesting. It's the first idea of what you can do with connectivity. The capacity of glasses are limited. It's still a smartphone, very powerful. But if you want to create very powerful algorithm, you could need to use external computer, like external server, to use big number of data or powerful algorithm with a strong computer. And with connectivity, especially not for now, they are already connected with Wi-Fi or Bluetooth. What we need is a very high-speed connectivity if you need to exchange a large number of data. And 5G is also, when I think about connectivity, is especially with 5G. Nevertheless, it's not so easy because you are working in a medical environment and you have two risks. The risk of cybersecurity. If you open those channels of communication, you have a risk to have pirates that enter in your system, and you have a risk to lose patient data. And it's something that we are very sensitive. Everybody is sensitive. So besides the technological aspect, you open a risk, and this is something you need to be careful.
So if I understand correctly, you don't just see AR as a way to translate the planning into the OR, but also to capture data during surgery that could then, let's say, improve planning for next patients.
It's just one way to think about data, but we have another way. Just inside the operating room, you have a lot of other computer or system. And the best one, I would say probably not the best one, in orthopedic, everybody is talking about robotic. Robotic is nice, but it's not the same way to think about robotic in the orthopedic industry and in the standard industry, like the Da Vinci. The current robotic system are robotic arm with a navigation system, but the navigation system is an old-fashioned navigation tool because it was created 20 years ago. Our way is to think about those accessories, like the robotic arm, to be connected with your glasses. When I talk about glasses, it's not just the glass, it's the computing tool, the connected tool, and the display. With the RS system, you can control a robotic arm. You can talk, you can exchange data with your instrument if they are equipped with a RFID chip. So it's a new world where of information you can connect wireless, you can control other system, and you can talk to the world. And our aim is to create a digitally augmented surgeons, not to give to the surgeon a lot of electronic tool like a robot, computer, and so on. It's just to give them additional power, like a super surgeons that will use new sensor, pre-compute very complicated algorithm to help them to take the right decision for their patient. And planning is part of this project.
I think it's interesting the way that you talk about this. It feels like you're saying for us, the AR is going to be the central technology that kind of coordinates maybe everything around it. Is that how you see it in 5 to 10 years? If you look at all the technology that are around, 3D printed instrumentation, maybe patient-specific implants, planning, robotics, do you see AR as the central technology component that binds all of these together?
Yeah, for not just for medical area. And I can tell you, I was an early adapter of the Google Glass, and it was a fail. So we need to learn from this failure 10 years ago. But we evaluate, the technology now is more powerful. You can have very light glasses. And I really think that it will be the major change, connected glasses in the future. And it will be the central point of everything in the world. You can still have a robotic arm in your operating room, but it's very difficult to move it from one operating room to the other one. It's big capital investment. If you can have the computer on your head, if you can move with this computer, if it can help you for every step of your surgery, or before and after to analyze patient motion if you want to follow it your patient. I don't want to plug a chip in surgeon brain, but it looks similar, an easy way to access data to make surgeons more powerful. They are expert, but they can find a lot of opportunities. If you are surgeon using a robot, they look like an assistant of a robot. So it's interesting to see also on a personal point of view. I will be a surgeon. I will feel good to have all the information and to have just a robotic arm as my assistant.
I feel a lot of enthusiasm and excitement around AR in this room. And Materialize Peter is also the one who is really championing AR, trying to be a little bit the critical mind in the discussion by maybe a bit of a provocative question. The first time we met Sebastien was about 10 years ago. And then we would probably be having the same conversation, but then on knee guides. You were in that industry and then together with Materialize championing this technology. And I remember those also as very exciting days to be part of that game. You know, all the surgeons wanted it. All the medical device companies were looking at how can we get this as quickly as possible into the market. And then yet, if you look at it today, never really reached a penetration in the market more than 10% of procedures being happening with surgical guides. Do you know why that is, and why will this be different for augmented reality?
Yeah, as I said, I had in my 25 years of experience, even standard navigation that failed to be a standard of care. The reason why is that it was complicated to use, and you had still additional cost per surgery that was a little bit expensive, capital goods or disposable. And in the last decade, you had two new families. So on one side, you had the robotic system, that is an evolution of the classical navigation with a robotic arm. But I think we did this the wrong way. I'm not against robotic. To make the answer simple, patient-specific guide was interesting compared to traditional navigation because it was easy to use. And it makes the surgery simple compared to the previous way to do traditional surgery with standard instrumentation or with navigation. It failed for two main reasons. The first one was logistic. That was complex. You need a preparative images. You need to do a planning. You need to have your patient data out of the hospital. You need to send your data for external treatment. But the main reason is that you are limited in your function. If you want to realize your planning, it's perfect. But something can happen during surgeries, and especially as I said before, patient is not just a patient in your patient with images, with a patient lying in supine position in the CT scan. You need to analyze motion, or especially for the knee, soft tissue balancing is part of your knee surgeries. And the failure of patient-specific guide, especially for the knee surgery, was not to be able to adjust your planning in the OR according to specific information you can record or see during the surgery. I think this is the main failure. Nice solution, easy to use, but with too much limited function and a logistics that was a little bit complex.
I think the advantage that you pointed out with AR and making the surgeon the superhero, because it gives him additional information to make important decisions during surgery. And that's maybe an important difference with knee guides, right? But then during surgery, you don't have that many options to deviate from your plan.
Exactly.
Okay.
This is what I think. It's more than just to be able to deviate from your plan, but part of the flexibility that can offer augmented reality compared to the patient-specific jig. It's something that is really an advantage, not just for augmented reality, for robotic also. You can change your planning in the OR, but you need to collect, to be able to collect those information during the surgeries, and to also, when you have a planning, it's a complex, most of the time it's complex algorithm. So if you want to change one position of your implant, it can have an impact on many parameters of your surgery. So to be able to compute that in real time with the new information you can get during surgery is also important. So planning, I think, is still important. In the future, we won't talk about preoperative planning. Planning will be integrated in the OR. My dream is to have images preoperatively, to get the images directly in the OR, to reconstruct automatically the 3D model from your images, so without external manipulation, and to have a planning directly on your patient. The next generation of product will be to see, not on a screen, your virtual implant on a 3D model of your scan, but directly on your patient, to see your 3D virtual implant on your real patient. This is the future. So that makes surgery easier. You won't lose time before the surgery. You can still want, you could have the surgeon willing to take time to prepare the surgery. But I think also that in the future, automatic planning will help surgeons to do the planning, and they will just fine-tune with the expertise to adjust the planning to the patient.
I'm a big believer of this technology as well, so I think I follow your potential benefits in terms of logistics, in terms of the ability to adjust indeed and do some things intra-op. I think one thing that is maybe a bit contradictory that I'd like to get your view on is that you said one of the challenges for guides was the need to have data go out of the hospital. How do you see that maybe the dynamics in the market have changed? Because in your dream, in your vision of where AR will go, I also see that interaction with data going out of the hospital, going out of the EOR as essential to realize that. So do you think that the minds of the market have changed, or is there something else playing here?
Hospitals want to protect patient data. Healthcare system want to protect healthcare data. So to put data outside of the hospital, patient data will be complicated, but anonymized data in order to create predictive biomechanical model outside that will help surgeons to take a decision during the surgery is still my vision. Mm-hmm. Well, I don't think that you need to export patient data for your current surgery. What I would like to do is to explore your PACS with virtual desktop, to go in your PACS, selecting your preparative data. Why not? Not just preparative data, to reconstruct automatically. Materialise is doing that well, to construct automatically with the computer that is on your glasses, and to get in real time your 3D model, to match this 3D model to the real patient, to get automatically your planning and to realize your planning with additional data you can get on your patient. That means soft tissue balancing or any kind of data you can get from the motion of your patient.
Yeah, I think it's an interesting view indeed to disconnect maybe patient data and personal data from data that you might need to do a calculation on. They're not necessarily one and the same, and indeed there might be a different expectation or requirement in the market for those. Yeah, I totally agree with that actually. Maybe a good time actually to ask where you're going next, because we talked about your history in personalized guides. We talked about Pixie and the focus on knee surgery, orthopedic surgery in specific. What's next after the knee for you, and why do you want to go in whatever direction that you choose?
When we discussed about patient-specific guide, we were thinking that it was the perfect solution. And we discovered time after time that it was not a perfect solution. So probably augmented reality will evolve also. The technology is moving so quickly that we need to be open and to be ready to see what will arrive in the next 3-4 years. I think it's the first time in my professional life can just see opportunities in this new technology. With standard navigation, with robotic, with a cutting guide, very quickly we were able to see the limit. Technology was nice, but the evolution by using this technology was limited. With this technology, because of the connectivity, because of the display, because of the computing, because of everything that is the heart of this technology, I have the feeling that the potential is open and nobody is able to see the limit. So this is what is interesting. But now, inside what is visible, I have enough to do for the next 10 years. So it's good for me. I'm 50, so I will do probably the rest of my professional life in this area. But still stay open. Don't see too close. Most of the people make a big mistake by seeing augmented reality just as a display. Mm-hmm. No, it's not just a display. It's more. And if you can just open your mind to the potential of this technology out of the display, you are already at the next step.
Yeah, the best is still to come for AR. Also has to do, if you compare to a robot, developing a robotic system, it takes so much time and money, and it's really something that only a few can pull off and be successful on, which is also what we see happening in the orthopedics industry at the moment, where you have really the big ones coming out with a robot. While with AR, it's way more accessible. You see so much startup activities around AR. It will be a much more competitive space in terms of pushing the boundaries of technology. So,
very important is also the cost of healthcare system cannot absorb all new technology at any price. We decide to work with off-the-shelf glasses. I have competitors that decide to create their own glasses really specific for this technology. but you can find really the limit of this model because you have healthcare systems that are not able to pay for that. You still have the US market, Australian market, and some European markets that can access high cost technology. But I was thinking that right now, by using off-the-shelf technology, smartphone now helps to develop glasses. This is the same kind of technology. So it helps also to reduce cost. With one robot, you can buy 100 augmented reality system, and the clinical benefit look like the same right now. If you want to create a new standard of care, you need to be sure that everybody will be able to use it. We have a lot of requests from India, from China, and this is a country with healthcare that need to work with a lot of people and with not the same level of reimbursement that the one we have. That's why also we decide to create new business model. If you are close from the software, you can create business model without disposable. Most all the system we had in the past were capital goods, expensive, plus disposable. You need to pay per surgeries. Even the PSI, the patient-specific instrumentation, the custom jig, was a single-use product. And we are the first solution without disposable. We created instruments that can go to the steam sterilization. So it's also new. And you pay for the service when you use the product. So the evolution is not just in the technology. It's also the way it will help to create a new standard of care by reducing costs, still with the same benefit for the patient.
And in trying to create a new standard of care, because we all know that robotics are seen also a big uptake and pushed by the big industry. Do you foresee like an epic battle in the coming 5 to 10 years between AR and robotics trying to outbeat each other? Or will it be more in synergy, as you said before, where augmented reality might be just a way to better inform robotic surgery or things like that?
Like for AR, robotic is a big world, and there is a confusion most of the time because most of the people are saying robotic, that is a component of tracking, of display, of planning. That is very important also in robotic, and a robotic arm. What we try to define with this new AR system is the component outside of the robotic arm. So my vision, and I'm sure that it will happen, it's our system controlling a robotic arm. And the robotic arm will be an option. What is the interest of a robot is to be precise in your surgery, that you can do that with an augmented reality system. And if you need more precision, and I'm not sure that for now you need this level of precision for the orthopedic, but anyway, if it's important for the surgeons, you can combine augmented reality navigation system with a robotic arm. It's not an opposition, but it's nice. It's really nice to see the robotic system worldwide. I am just concerned by the additional cost. We have surgeons that make a calculation that by using a robot, the additional cost per surgery is 3,500 euro per surgery more. And for now, I have to say that I don't see a clear benefit of this additional cost. You can have benefit, but I cannot see.
Let this be an invitation for somebody from Stryker or Zimmer Biomet to join us on this podcast next episode. Yeah, I think it's a very fair argument, and I wonder what their answer is to that.
They have the potential to prove that it's efficient, and they are probably also working on the next generation. But for me, it's a tool to develop. It's a platform to develop probably a next generation. Currently, I don't see that, and probably augmented reality also at the first level is a tool to introduce this new technology. So I'm not against robotic. And I think the future probably will be for specific joint surgery to combine both. You can find advantage in both.
I totally agree with that. I think also it will help the sustainability in the end. If you can eliminate disposables, if you can build on more generic hardware with glasses and then use the robotic arm where it might be most useful, in those cases where you need the very high accuracy, in the end, it will help the scalability. It will help reach more patients with preoperative planning, also with proper execution.
What is important is the patient benefit at the end. That's it. It's not just to have a tool for fun. It will have an impact on the patient. And this is what we need to be. It's not just a toy. It's a tool to help surgeons to perform better surgery. And I think one big advantage of this new technology is to be less invasive at the end, to be more precise in your surgery, one point, to be less invasive. It's another big advantage of those technology.
You're a mind reader, Sebastien. We actually had our question on our page here to ask where the toy versus tool, where the borders were, and you actually used the same analogy yourself. You're reading our minds on what we're thinking to ask you. It's time to close off this episode. It was a very exciting discussion. Maybe I'll leave the final question to you, Sebastien. Provocative question, maybe, or the very futuristic question.
Well, I'm just curious. Let's say in the midst of your career, and let's assume that there's a very unfortunate situation that arises where you will need at some point, maybe 20 years from now, a knee implant. What do you hope that the industry can do by that time, and it's not possible today?
More expertise on knee. And one issue with knee is that 30 to 40% of people are thinking about their knee every day. It's not the case for hip, for example. You can forget your hip. For knee, you have 30% of your knees that are not forgotten. And the dream of everybody is just to have a forgotten knee. It's a combination not just of an implant design, it's a combination of multiple factors. Ambulatory surgeries that can help you psychologically to think less about outcome and about the surgery is one point. Less invasive surgery is another point. Patient-specific instrument implants is a new way of thinking implant for patient, but for now, we don't have a proof that it has clear clinical benefit for the patient. But my dream will be to have a knee in ambulatory with best fitting implant with a predictive biomechanical analysis of this knee according to my specific anatomy. And to do that with a minimal invasive surgery, this is what I would expect.
I think that's a nice expectation to have and shows there's still some work to do for entrepreneurs and innovators like yourself. Thanks a lot, Sebastien, for this really energizing conversation, for talking to us about your vision on augmented reality and in healthcare. We learned a lot of things, and that AR will be there to make surgeons be like superheroes, but that will also be a technology that really allow us to drive the costs down of healthcare. And, with that, hope that we're 2, 3, maybe 10 steps closer to making sure every patient can forget about their knee in 20 years from now. That would be fantastic. So we highly appreciate you sharing your insights with us on 3D Players, a podcast where we explore trends, insights, and innovations in personalized and sustainable healthcare. We were your hosts, Sebastien de Boot and Pieter Slagmolen. We thank you a lot for listening and join us in the next edition.